Good morning, students. Today I am going to discussing about center of mass in the chapter system of particles. Subtopic center of mass. So what is center of mass means? Everybody know. For example, just you consider the body. It consists number of mass particles m1, m2, m3 and so on mm. Total mass of this body is supposed to be concentrated at one particular point. That point is called center of mass. So center of mass is nothing but total mass of the body is concentrated at single point. That point is said to be center of mass. For example, just you consider two particles of mass m1 and m. They are separated by a certain distance d. So the center of mass of these two particles lies on the line joining these two particles. Here or here or here, where it is lies. So for example, m2 is greater than m1. In that situation, the center of mass of these particles lies near to a heavy particle always. Center of mass always lies near to heavy particle. So m2 greater than m1, that means center of mass may be at this position. For example, m1 is greater than m2. In that situation, center of mass is near to m1. That means here, here, or if m1 is equal to m2, in that situation, center of mass is exact at midpoint. Now I am going to, for example, m2 greater than m1. In that situation, the center of mass is nearer to heavy mass, that is m2. So what is the position of the center of mass from this m1, or what is the position of center of mass from this m2? That means distance of the center of mass from the first particle, distance of the center of mass from the second particle. So you can calculate here, from here to here, just assume myself d1. Here also assume yourself, this is d2. When I am saying center of mass this point, the moment of mass, that means the product of mass and length, this side must be equal to this side. That is called moment of mass, not momentum, moment of mass. So that you can write as m1 d1 is equal to m2 d2. From that you get here m1 d1 is equal to m2. In place of d2 you can write as d minus d1. So by solving that we get here the distance of the center of mass from the first particle d1 is equal to m2 d by m1 plus m. Similarly d2 also we can get here. Similarly d2 also we can write as m1 d by m1 plus m. So that is the center of mass of the two particles of the system. The distance of the center of mass from the first particle d1, the distance of the center of mass from the second particle is d2. That values are get d1 equal to. So on this basis one problem is there. For example, HCl molecule separated and Cl separated by distance 0.0682 degree Armstrong. For example, what is the position of center of mass of this molecule from the hydrogen atom or from the chlorine atom? So from that we can simply calculate it. So just assume yourself that's d1 and this is the d2, but we don't know where is center of mass. Just assume d1 from the first particle. The center of mass is at distance d1. From the second particle it is at a distance d2. From here to here distance is d equal to this value 0.682 like that. By using this formula, d1 equal to, and by using this formula d2 equal to, so d1 equal to m2 d by m1 plus m2. m2 means here I am taking this is the m1 and this is taken as here m2. From that we calculate the d1 value and also d2 value. The same situation, for example, two particles m1 and one more particle m2 separated by distance d. When they are freely released, that means like this, in the free space they are freely released because of gravitational force. They are attracted to each other. That gravitational force, not by the earth now. In between these two, just you consider the gravitational force in between these two particles. So that due to the gravitational force, they are attracted with each other. From Newton's second law, gravitational force is always attractive force. That's why they are attracted with each other. When they are attracted with each other, they are collided at any point. The two particles must be collided at its center of mass only. When they are freely released, the two particles are collided or meet with each other at center of mass. That means now they are freely released. Now the first particle is traveled from here to here and second particle is traveled from here to here. Now they are meet at the center of mass. What is the distance traveled by the first particle before to collide with the second one? Or what is the distance traveled by the second particle before to collide with the first one? I am just saying they are collided with at exactly at the center of mass. That's why the distance traveled by the first particle is nothing but simply d1. The distance traveled by the second particle here is nothing but simply d2. We know the value of d1. m1 m2 d by m1 plus m2. And we know the value of d2. m1 d by m1 plus m2. Before collision, the distance traveled by the first particle, distance traveled by the second particle, nothing but d1 and d2. The same way, what is the velocity of the particle at this position? What is the velocity of the second particle before collision at center of mass? Here we know the formula from law of conservation of linear momentum. m1 v1 is equal to, write as m2 v2, but kept here minus because first particle moving like this, second particle moving like this. From that we get here m1 v1 is equal to minus m2 v2. So from that the ratio of velocities of two particles when they are collided at their center of mass position, we get here v1 by v2 equal to minus m2 by m1. Take more, no problem. That is the ratio between velocities of the two particles when they are collided at a center of mass due to their internal forces. Because due to the internal forces, when the particles are moving like this, there is no change in position of center of mass. Because internal forces does not affect motion of the center of mass or position of the center of mass. So we can write as a v1 by v2 equal to m2 by m1. So just consider 2 kg and one particle and one more particle I am taking as a 3 kg. They are separated by distance 4 meters. They are collided with each other. At what distance? What is the distance traveled by the first particle before collision? What is the distance traveled by the second particle before collision? Two particles are freely released. They are exactly collided at the center of mass. From the first particle, I am taking this in the m1, I am taking this in the m2. So from the first particle, the distance covered by the first particle is nothing but here d1. The distance covered by the second particle is nothing but here d2. So we know the formula d1 is equal to m2d by m1 plus m2. So that equal to get here 12 by 5. That equal to get here 2.4. The same way d2 is equal to total 4. This point 2.4, 4 minus 2.4, 1.6 are calculated by using the formula. d2 equal to m1 d by m1 plus m2. 2 4 jar 8 by 5. That equal to get here 1.6. The distance before collision 2.4 or 1.6. Traveled by the first particle, traveled by the second particle. What is the ratio of their velocities? We get here v1 by v2 is equal to m2 by m1. That means we get here m2 by m1. m2 means 3 by 2. That is what we get here 1.5. The ratio of these velocities of the two particles before collision. So that is the two particle system. For example, if these two particles are placed on an axis, either x axis or y axis, just I am considering single now, only axis, two particles. This is the x axis. I am just taking this the m1 and one more particle m2. What is the position of center of mass when they are placed on the straight line, either x axis or y axis, z axis, whatever it may be? To calculate the center of mass of the positions, reference frame is required. Reference frame is nothing but coordinate system. So this is I am taking as a origin. From the first origin, the first particle is at a distance x1. From the origin, second particle at a distance x2. So what is the position of center of mass of these two particles when they are lies on the axis? Just myself assuming this is the position of center of mass. So from the origin, the coordinate of the center of mass is I am taking x. When I am saying this is the position of center of mass, then from here to here we have the value xcm minus x1. So from here to here we have the value I am taking as d1 and this is I am taking as a d2. So here d1 is equal to xcm minus x1 and d2 is equal to x2 minus xcm. From that, you can write as you know the rule m1 d1 is equal to m2 d2. Substitute the value. So finally you get the position of center of mass of the two particles when they are lies on x-axis. Xm equal to get here m1 x1 plus m2 x2 by m1 plus m2. So that is the position of the center of mass when they are lies on the x-axis. Similarly, if the particles are lies on the y-axis, we get here y coordinates m1 y1 plus m2 y2 by m1 plus m2 and so on. For example, the particles are placed in a plane. This is the particle m1 and this is the particle m2. From this origin, coordinates x1 y1. Here also coordinates x2 y2. So first particle and second particle. So the center of mass of the system maybe lies here, whatever it may be. So that can be calculated by using same formula. We get here xm equal to m1 x1 plus m2 x2 by m1 plus m2. The same way ycm is equal to get here m1 y1 plus m2 y2 by m1 plus m2. But then the coordinate maybe center of mass here. So that means we can take as xm and ycm. So from the origin, the distance we can take as a position vector. RCM bar equal to xcm I plus ycm j. So distance of the center of mass from the origin d equal to under root of xcm square plus we get here ycm square. So that is the position of the center of mass calculation. For example, just to consider 3 x-axis, y-axis, z we get here x1 y1 and one more coordinate z1. Here also x2 y2 and one more coordinate that is z2. So the position of the center of mass also we get here xcm, ycm and also zc2. Here also we get here zcm k bar. So from that here also we get here zcm square. So that is the position of the center of mass. For example, just I am taking a mass 5 kg and one more mass also 5 kg. What is the position of center of mass? We can simply say both are having the equal mass. That means exact at midpoint. For example, the two particles are separated distance 10 cm. Then the position of the center of mass is exact at midpoint because both are having the same mass. That's why we can simply say here to here 5 cm. Here also we can say 5 cm. So the distance of the first particle. For example, this I am taking as a 1 kg. This is the 5 kg. In this situation, the position of the center of mass is nearer to heavy mass. That means is nearer to 5 kg. That means I am taking this one. Center of mass. From here to here, distance is d1. From the formula m2 d 10 meters calculation purpose. m2 d by m1 plus m2. 50 by 6, 6 8 jar, 48, 6 3 jar and so on. Distance of the d2 is equal to, we get here same m1 d by m1 plus m2. 10 by 6 means 1.6 and so on. So that is the calculation. For example, in this problem, the distance is I am taking as d1. Here also the distance is d2. When the bodies are displaced to center of mass of this system, just I am taking this is the m1 and this is the m2. Initially the center of mass of the system is at this position. Now the body m1 is displaced from this position to this position and that is moves towards the center of mass by a small distance. What happened? There will be some change in position of the center of mass because when they are exactly like this, some mass is moving from here to here. That means moment of mass changes. That's why position of the center of mass also changes. To keep the center of mass at this position exactly, we have to move the second body also. The second body must be moved in opposite direction to first body. If first body is moved towards the center of mass, that means from left to right by a distance. Just I am taking as a delta x1. What is the distance? Move to the second body to keep the center of mass exactly at the same position. This center of mass ikkada exactly undali ante ఈ సెకండ్ బాడీని we have to move in opposite direction by small distance delta x2. So that is the condition, must be in opposite direction. So this is also moves through a small distance by distance delta x. That can be also calculated. You know the condition, moment of mass m1 d1 is equal to m2 d2. In the situation you can write as here x1, here also you can write as here x2. So the distance moved, the shift of the first body from original position to the second body, the first body shifted by small distance, that is delta x1. So in that case m1 delta x1, here also you can write as here m2 into delta x2, but you get here minus because opposite direction. For example, in this case this is the 1 kg, I am taking this is the 5 kg, this is also 5 kg. Distance between these two 10 meters. First, initially the center of mass is exact at midpoint, that means here 5 centimeter. Here also you can take as here 5 meters. 5 kg. This is also 5 kg. Separated by distance 4 meters. No need to 10. 4 meters. Exactly. The center of mass is exactly midpoint. That is 2 meters. Here also 2 meters. Now the 5 kg is shifted from here to here. The 5 kg is shifted to like this by a distance 1 meter. Simply without any subject knowledge, generally two bodies are here, center of mass is exactly midpoint. When it is moved by distance 1 centimeter, to keep the balance or to keep the center of mass exactly at the same position, this body also should move in opposite direction by the same distance. So because 1 centimeter, because both are having the same masses, 5 kg, 5 kg, this is also moves here. In this new position, this is here 4 centimeter, here also we get the 4 centimeter. Again balance is condition. For example, unequal masses, I am taking this here 3 kg. Distance of the center of mass from here 2 meters, from here 2 meters, no, because 3 kg, 5 kg. So distance of the center of mass d1 is equal to m2d by m1 plus m2. But the center of mass is maybe at in one position, just that is the center of mass position. Now the 3 kg mass is shifted towards the center of mass by a distance 1 meter. That means 3 kg is shifted from here to here. To keep the position of center of mass at same position, this body also should move in opposite direction through what distance? So ఇది కూడా ఇక్కడ మూవ్ చేయాలి. ఎంత డిస్టెన్స్ మూవ్ చేయాలి? By using the formula m1 delta x1 is equal to m2 delta x2. We are giving minus, that is opposite direction. So m1 means I am taking here 3 delta x1, the distance shifted by the first body 1, that equal to minus m2. M2 means I am taking here 5 delta x2. We have to calculate. So from that 3 by 5. So that equal to delta x2. 3 by 5 means we get here 0.6, that equal to delta x2. So the second body shifted in opposite direction to the first body by a distance 0.6 meters. So that is the calculation of the shifting. When the bodies are shifted like that, the second body is shifted to keep the center of mass at the same position. So in the same way we have to calculate just now. I am taking the x-axis, y-axis, two particles m1, m2, the positions x1, y1, and this also you can take as x2, y2. One more particle I am placing here. So initially two particles, the center of mass of the particles xm comma ycm. That means this is I am taking at the two particle system center of mass xm and ycm. So first particle coordinates, second particle coordinates, center of mass coordinates. Now I am giving another particle of mass m3. another particle of mass m3, there is no change in center of mass of the system. Then what is the coordinates of this particle? Where should we have to keep the particle such that the center of mass of the two particle system does not change? In that case, just assume yourself the position of or the coordinates of the third particle x3, y3. So in case we can write as x3 equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3. And y3 is also, before keeping third particle, the system contains only two particles, so we can write as XM of the three particle system, XM of the two particle system. Okay, you can write as m1 x1 plus m2 x2 by m1 plus m. Just I am taking here xm dash when third particle is added. But my condition, the position of the center of mass does not change. So in this case, you can write as here xm dash is equal to xm. So from that you get here m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, that is equal to get here m1 x1 plus m2 x2 by m1 plus m2. So from that you get the calculations, you got the answer, the position of the value of x3. The same way you have to y3. For example, I am saying when you are placing the third particle at a position of x3 comma y3, or we don't know, when you are placing the third particle, the position of the center of mass is shifted to origin. Initially, when you are having the two particles, the center of mass of the body is coordinates xm and ycm. But when you are placing the third particle, the center of mass of the system shifted to origin. That means in this situation, the new coordinate when you are having the three particles becomes 0. So from that, what is the position of the third coordinate? You get here. This is also 0. So from that we get here m1 x1 plus m2 x2 plus m3 x3 is equal to 0. So from that x3 equal to minus m3 by m1 x1 plus m2 x2. That is the coordinate of the third system. When we are adding the third particle, the center of mass shifted to origin. The same y3 also you can write as here. Same concept. So that is the position of center of mass. For example, general problem. Take a triangle, three particles, mass m1, m2, m3, m1, m2, m3. So side of the triangle just assume as A. What is the position of center of mass? If all are equal, then the center of mass is exactly at the center. m1, m2, m3 all have the equal mass. Then the center of mass is at this position. But they have the different masses. What is the position of center of mass? The center of mass position can be calculated by using coordinate system, x-axis and y-axis. Here the coordinates x1, y1, that becomes here 0, 0. Here the coordinates of the second particle, x2, y2. Coordinates the first one. m1 related to coordinates x1, y1, that you could get here 0, 0, and the related coordinates of the second particle, we have the x2, y2, that you could get here a, 0, and the third particle m3, the coordinates are here x3, y3. To calculate the center of mass, positions of the particle must be required, x1, y1, x2, y2. That means we get here x3. From here to here x3, this is the y. x3 is nothing but here a by 2. y3 is nothing but height of the equilateral triangle of side A. So we get here root 3a by 2. So they are the coordinates. By using the coordinates, xm equal to m1 y1 plus m1 x1 plus m2 x2 plus m3 x3 by 7. And also ycm equal to, we have also calculated. The same way, we are taking the one triangle and we are taking the one square. In that situation also, square, particles of different masses, x-axis and y-axis, m1, m2, m3, m4. Here also what is the position of center of mass? Same. m1 coordinates we have to find out 0, 0 because it is origin. Next side of the square just taking as here A. That value may be 1 meter, 2 meter, whatever it may be. So M2 is equal to x2 y, sorry, M2 coordinates x2 y2 a comma 0, M3 coordinates x3 y3 that equal 0 comma a, M4 coordinates x4 y4 that equal, you can take as here a comma a. Substitute the values xcm m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. Ysn also m1 y1 plus m2 y2 plus m3 y3 plus m4 y4 by m1 plus m2 plus m3 plus. That is the xcm to get and also ysm to get. Maybe here, or it may be, for example, at this position. What is the distance of the center of mass from the origin? So this is value. This value is required. So you know the xcm and ysm. So RCM bar is equal to under root of, we get here xcm square plus ysm square. That is the distance of the center of mass from the origin. Position of the center of mass means xcm and ysm. That's enough. For example, in the same way, a parallel M1, M2, M3 and one more particle M4. Find out the position of center of mass. X-axis and this is the y-axis. Here side A, here breadth and taking as a B. What is the position of center of mass? I am taking this is the theta, and also this value also becomes just for a theta or alpha, beta and Jacobi. This value position of the center of mass. Coordinates of the first particle m1 nothing but x1 y1 is equal to get here 0 comma 0. Coordinates of the second particle m2 x2 y2, here we get here a comma 0. Coordinates of the third particle, that means x3 y3, that equal to, it is not on y-axis. When it is on y-axis, we can simply say b comma 0, so 0 comma b, but it is not on y-axis. So from that, this is b. Okay, now we are to this value. This is x3 and this become y3. x3 and this is the y3. Here also, from here to here x4 and this one y4. What is the value of x3? Sin theta opposite by hypotenuse. I am taking theta here only. Sin theta is nothing but opposite by hypotenuse. So sin theta is equal to get here x3 by hypotenuse b. So x3 is equal to b sin theta. So I get here x3 value how much? b sin theta. The same way y3, this one. This is theta, this value cos theta equal to adjacent by hypotenuse. So cos theta adjacent y3 by hypotenuse b. From that y3 equal to get here b cos theta. Now the coordinates of fourth particle m4 equal to x4 y4, that equal to x4 from here to here. This value is no, but this value is b. So from here to here, this for x4, a plus this value. Here theta, this is b, sin theta, we get here same value, a plus b sin theta. If theta values is not same, then you get the different values from a plus b sin theta. And y4 is here, this one is y4, y3, y4, both are same. You get here b cos theta, and I am taking theta is same. So in that situation, substituting the value m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 by m1 plus m2 plus m3 plus m4. So you get the xm value and also ysm values. In that we have to calculate all problems. First, before going to calculate the center of mass, we have to require coordinates of the particles. After that, using the only one formula. For example, two particles of mass m1 and one more particle m2 are moving with velocities v1 and v2. Now we will be discussing about all are at rest. Now I am going to particles are in motion. When particles are in motion, the center of mass of the particle system is also in motion. What is the velocity of center of mass? Simple. We know the formula. xm equal to m1 x1 plus m2 x2. Two particles is there. So by m1 plus m2, differentiating with respect to time, you get here VCM. Here you get here velocity.